Every second, our entire galaxy is hurtling through the cosmic abyss at an astonishing speed of over 600 kilometers per second. We are not merely drifting, we are being pulled toward a precise point in the deep cosmos. Across hundreds of millions of light years, thousands of neighboring galaxies are caught in the same colossal cosmic current. They sweep through the void in a synchronized celestial migration toward a colossal gravitational anomaly that dominates our galactic realm. Yet when we train our most powerful telescopes toward the ultimate target of this grand journey, we encounter a wall of impenetrable darkness. The architect of this immense movement remains hidden, obscured behind the brilliant veil of our own celestial backyard. Cosmologists have named this invisible behemoth the Great Attractor. Investigating this invisible giant forces us to confront the profound limits of human perception and the immense hidden architecture of space. To understand what drives this monumental drift, we must examine the physical barrier blocking our vision. Our solar system rests within the dusty disk of the Milky Way, surrounded by billions of glowing stars, dense gas, and interstellar dust clouds. When we look out into deep space, this dense galactic plane creates a vast blind spot across 20% of the nocturnal sky. Astronomers call this obscured cosmic corridor the Zone of Avoidance. For generations, this obscured region shielded its secrets from classical optical astronomy. Starlight from distant background galaxies was scattered and absorbed by intervening cosmic dust, leaving a dramatic void in our early charts of the cosmos. In the late 20th century, however, researchers analyzing the cosmic microwave background radiation noticed a subtle asymmetry. The relic heat from the early universe was slightly warmer in one direction and cooler in the opposite direction. This thermal variation revealed an undeniable truth. Our local group of galaxies was accelerating toward a specific point in space far faster than the uniform expansion of the cosmos could account for. Something possessing the mass of tens of thousands of Milky Ways was exerting an irresistible gravitational pull across the vast void. To peer behind the dusty curtain of the Zone of Avoidance, astronomers turned to radio wavelengths and infrared technology, which could pierce through the thick interstellar dust. As these advanced instruments mapped the hidden sky, an extraordinary picture began to emerge from the darkness. Behind the stellar dust lay dense concentrations of previously invisible galaxies, clustered tightly together in massive cosmic nodes. The Great Attractor was not a singular cosmic monster or a colossal black hole, but rather a vast, dense concentration of mass, a supercluster region packed with thousands of individual galaxies bound by gravity. When we step back to behold this structural hierarchy, the true architecture of our cosmos comes into breathtaking focus. Galaxies are not scattered randomly like dust across a silent canvas. Instead, they assemble into delicate threads, filaments, and dense knots, forming a vast cosmic web that stretches across hundreds of millions of light years. Our Milky Way resides within a small celestial neighborhood called the local group, which is itself drawn toward the vast Norma cluster at the heart of the Great Attractor. Yet, as mapping techniques improved throughout the early 21st century, a startling discrepancy arose within the equations. The measured mass of the local galactic clusters within the Great Attractor was immense, yet it was still insufficient to explain the staggering velocity of our cosmic migration. The pull was simply too strong to be generated solely by the visible matter locked within those newly discovered galaxies. This realization led astrophysicists to explore the pervasive role of dark matter, the mysterious substance that forms the invisible scaffolding of the universe. While normal matter interacts with light, dark matter reveals itself exclusively through its gravitational influence. Huge halos of dark matter engulf galaxy clusters, adding tremendous invisible mass to the cosmic web. Even with dark matter included, however, the strange gravitational anomaly hinted at an even larger structure lying far beyond the immediate target zone. By analyzing the coherent flow of tens of thousands of galaxies, researchers uncovered a vast cosmic continent of mass spanning more than 500 million light years. In 2014, scientists defined this immense home supercluster and named it Laniakea, a Hawaiian term meaning immense heaven. Our Milky Way is merely a tiny outer strand on the fringes of this colossal, flowing cosmic watershed. Within the vast expanse of Laniakea, all gravitational paths converge inward like rivers carving their way toward a central basin. The Great Attractor acts as the major gravitational valley within this localized cosmic continent. Millions of stars, gas clouds, and dark matter filaments flow along these invisible gravitational channels, moving gracefully toward the central heart of the supercluster. Yet the story does not end at the heart of Laniakea. Beyond the boundaries of our home supercluster lies an even more daunting cosmic giant that exerts its influence across an incomprehensible expanse of space. Astronomers tracking the motion of Laniakea itself discovered that our entire supercluster is being pulled toward an even larger mass concentration known as the Shapley Supercluster. This extraordinary realization reshapes our understanding of scale and connection in the cosmos. We inhabit a dynamic universe where nothing is truly motionless. While the cosmic expansion driven by dark energy pulls distant galaxy clusters away from one another over immense cosmic time, gravity remains the supreme sculptor on localized scales, drawing entire superclusters into intimate, grand dances across the void. The interplay between cosmic expansion and localized gravitational attraction reveals a delicate equilibrium operating across the universe. On the largest scales, space stretches endlessly, driving distant realms beyond our horizon. Yet within supercluster watersheds like Laniakea, gravity holds firm, binding thousands of galaxies together into an interconnected web of light and mass. As mapping techniques continue to refine our cosmic ocean, fundamental questions remain unanswered about the ultimate fate of our galactic journey. Will the accelerated expansion of the universe eventually overcome the gravitational pull of the Great Attractor, or will our distant descendants witness a mega-merger of cosmic proportions in the deep future? Observing through the dense obscuration of the Zone of Avoidance continues to challenge our most advanced space observatories. From early optical sky surveys to modern space-based infrared observatories, our journey to comprehend this anomaly reflects humanity's unyielding determination to map the unseen. Each era of technological innovation has unveiled another layer of cosmic structure, transforming an enigmatic blank spot on our maps into a thriving, dynamic metropolis of galaxies. Looking out from our small planet, nestled within an ordinary spiral arm of the Milky Way, we find ourselves bound to a profound cosmic destiny. We are travelers upon an invisible river of gravity, racing alongside thousands of sibling galaxies across the immense expanse of Laniakea toward a destination concealed behind a curtain of ancient starlight. This grand galactic drift serves as a poignant reminder of our profound connection to the wider cosmos. The very atoms that form our bodies were forged in the stellar furnaces of past generations, and now those same atoms participate in a sweeping celestial journey spanning hundreds of millions of light years across the infinite void. The Great Attractor stands not as a terrifying void, but as a monument to the majestic hidden architecture of space. It invites us to peer beyond our immediate horizons, reminding us that even when obscured by dust and distance, the invisible forces of the cosmos are constantly shaping our journey through the ultimate frontier.